x equals to a sine of pt and y equals to b of cos pt, then find out d square y by dx square at t equals to 0. Now let's try to differentiate x and y with respect to t, parametric differentiation, calculus. So we have dx by dt is a into cos pt and the derivative of pt is equal to p. So we will get ap cos pt. Now let's find out what is dy by dt. Y is b cos pt. So dy by dt will be b into derivative of cos pt, that is minus sin pt, into derivative of pt, which is equal to p. So dy by dt is equal to minus b p sin pt. Now what is dy by dx? Dy by dx is equal to dy by dt divided by dx by dt. So let us do that. We will divide dy by dt with dx by dt. We will get minus bp sin pt divided by ap cos pt. We can cancel p and p. We are left out with minus b by a tan pt. Now this is where we have to understand what is d square y by dx square. Now d square y by dx square is d by dx of dy by dx, that is nothing but d by d theta of dy by dx into d theta by dx. Now this video was made only for this d square y by dx square. How we have to do that? That will be d by dt of dy by dx and multiply that with dt by dx. So just remember that once you got dy by dx in terms of the other parameter or basically t, then differentiate that one more time and multiply that with dt by dx. Now what is d by dt of dy by dx? That is minus b by a tan pt derivative, minus b by a tan derivative is secant square, so secant square pt, and pt derivative is p, multiply that with dt by dx, that is 1 by dx by dt, so I can write 1 by ap cos pt. Now again p and p will cancel, we are left out with minus b by a secant square pt divided by cos pt. We can simplify this further, or we just know that t equals to 0. So we can directly substitute t equals to 0 and see what happens. That will be minus b by a square. T is 0, then pt is also 0, cos 0 is 1, secant 0 is also 1. So simply we have minus b by a square into 1, and that is equals to minus b by a square. When t equals to 0, t is 0, pt is 0, cos pt is 0, cos pt is cos 0 is 1, cos 0 is 1, secant 0 is also 1, secant cube 0 is also 1. That means we just have d square y by dx square equals to minus b by a square. Now as part of parametric differentiation, now we know that parametric differentiation means basically we are representing x and y in terms of other parameter, either theta or t. In such scenarios, when you have to calculate the value of d square y by dx square, your dy by dx will be in terms of the parameter either theta or t. So when you do d square y by dx square, you have to remember that d square y by dx square is d by dx of dy by dx, but the dy by dx is now in terms of parameter t or theta. So you have to differentiate again with respect to that only. So you have to write down d by dt of dy by dx and multiply that with dt by dx. So this is the only step very important you have to remember. So we will take dy by dx which is there in terms of the parametric variable, we differentiate it one more time and multiply that with dt by dx. After that, if they just ask you d square y by dx square, you can give it. Suppose they gave you, we want to know when theta is 30 degrees or t equals to 0. Substitute that value for the parametric variable and get your answer.